All right, this is section 5.3. Hopefully it's not as long as section 5.2, which was exceedingly long. Let's look at the warm-up. Section 5.3 is all about matching rational functions to graphs and understanding the graph of a rational function from its equation and the equation from its graph. So let's just pick some sort of rational function here. How about x plus 1 times x minus 3 over x plus 2 times x plus 4 and times x. Okay. So what do we like to know about rational functions? We like to know the roots, the vertical asymptotes, the horizontal asymptotes, maybe the y-intercept, if there is one. There isn't always one. There's no y-intercept here, and you'll see why. Okay, so first of all, for the roots, we want the numerator to be 0. Because if it's 0 here, then it's multiplied by anything else, it's still 0. If it's 0 here, multiplied by anything else, it's still 0. So our roots are x equals -1 and x equals +3. Our vertical asymptotes, we want the denominator to be 0. Because if the denominator is going to 0, the whole thing's going to get very, very large. And so we have a vertical asymptote at x equals 0 for that one, x equals -2 for that one, and x equals -4 for that one. For a horizontal asymptote, horizontal, that's close enough, asymptote, we want to compare the rational function to its simplest, I'm going to call it companion function. What I mean by that is if we have a rational function, we say, what is it most like? Well, if I look at f of x, I'll write it again. If I were to multiply this out, it'd be x squared plus other terms on top, and it would be x cubed plus other terms on the bottom. And so our simplest companion function is not worrying about the other terms, because remember, this only affects the interior behavior of the function, not the end behavior. So then I just look at this one here, and that's basically like 1 over x. And I need to remember that 1 over x has a horizontal asymptote at y equals 0. So my function has a horizontal asymptote at y equals 0. And if I want my y-intercept, I'm going to plug 0 into my function. So I get 0 plus 1 times 0 minus 3 times, oh boy, here I have a problem, right? Because I'm trying to divide by 0. So this, there is no y-intercept. I knew that. I mentioned it before, and I forgot it. I forgot that fact, but it didn't matter because when I did the math, it reminded me. So you don't have to remember everything the first time. So now we have the information about this function. I'll rewrite the key pieces on this page. We have our formula, x plus 1 times x minus 3 over x times x plus 2 times x plus 4. We have our roots at x equals -1 and x equals +3. We have our vertical asymptotes at x equals 0, x equals -2, x equals -4. And we have a horizontal asymptote at y equals 0 and no y-intercept. So now I can sketch a good enough graph. I'll start by labeling my zeros. Here's -1, here's +3. Then I'm going to put in my vertical asymptotes. There's one right there at x equals 0. There's one right here at x equals -2. And there's one right here, so that's -2. There's one right there at x equals -4. All right, and so now there are a couple possibilities. There's a couple different ways this could all go, but I happen to know from the formula how it should look, and so you can just trust me on that. So it's going to, I'll use red. It's going to, as you go out towards -infinity, it's going to approach, let's put our horizontal asymptote in there too. There, that's y equals 0. It's going to approach y equals 0. It's going to come down like this. I didn't know what it looked like, so I went to Desmos so I could do this correctly for all of you. It's actually going to come down and turn around and go back up, which is maybe a little bit beyond what we're looking at, but I just came up with this example, so that's life. And then it's going to come up, it's going to cut through there, pretty much straight, because the multiplicity of that's a 1. And then it's going to come up this way and kind of come back down like that. And so that's what we're going to have for this function, sketching our good enough graph based on what information we've learned. All right, so that's our warm-up, which is sketching a graph from the equation. A lot of 5.3 itself is figuring out the formula from the graph. So I'm going to do some of that. So this is 5.3. I'm going to skip question 2 because that's pretty much what I did for the warm-up. Or sorry, I'm going to skip question 1 in 5.3. I'm going to go to question 2, which asks you to match formulas to their graphs. But instead, I'm going to draw a graph and we'll come up with a reasonable formula for that graph. This is one of the more challenging parts of Math 111 because there's so many different possibilities for what rational functions can look like. And you see the whole big picture and it can get overwhelming. So I'm going to be using my hands a lot to help make this whole thing a lot simpler. So first I'll draw my axes. I'm going to label things a little better than I normally do. I'm going to draw in I'm going to draw it in one place where my function is 0. That's going to be the value 2. And I'm going to draw in some vertical asymptotes. This is going to be the point -3. And that's going to be the point 5 right there. And I'm going to draw in a horizontal asymptote. Y equals 0 here. And now I'm going to trace in a possible function. I'm getting quiet because I'm thinking really hard. I'm not just zooming through this like I normally do. Okay. All right, so how do I come up with a possible formula for this function? And we do this slowly and we go backwards. So when coming up with a graph from a formula, we identify the roots, the vertical asymptotes, the horizontal asymptote, and if there's a y-intercept. Which technically I could put in right here. I could say that's 0, -2. Okay, so first let's find the roots. And there's 1, and it's x equals 2. Now let's find the vertical asymptotes. So that's right here. That's at x equals -3. And there's another one here at x equals +5. Now let's check our horizontal asymptotes. So we have a horizontal asymptote at y equals 0, which can tell us something about how the function should end up looking, and a y-intercept at 0, -2. So I know that a rational function has the zeros in the numerator, so it should have an x -2 up here. It has the vertical asymptotes in the denominator, so if the vertical asymptote is at -3, the factor is x + 3 and x -5. It's got some coefficient. I don't know what it is, so I'll just put an a in. And now let me check and make sure this is going to end up going to 0. The closest companion function it looks like is 1 over x, because you have an x over an x squared. And yes, that does look like, that does have a horizontal asymptote at y equals 0. So that makes sense. Now, how do I find out a? I use that piece of information that I have. I know f of 0 should equal -2. So -2 should be a times 0 - 2 over 0 + 3 times 0 - 5. So a times -2 over -15 should be equal to -2. And so if I do that multiplication, I'm going to get a is 15. And so now I have my full formula. Did I do that right? I made one error. -2 divided by -15 is positive. So let me slow down a little bit. So if I'm here, my next step would be 2 over 15, a equals -2. So a equals -2 times 2 over 15. Sorry, times 15 over 2. And those cross out, and I get a equals -15, not a equals +15. And so my formula is going to end up looking like that. Now, what I went through is more, on the one hand, is more difficult than just matching, because I'm having to do a lot of arithmetic and things like that. But on the other hand, you basically have to go through this process in order to do the matching anyway. Sometimes you can do some shortcuts, and we can talk about that in class. Let's just do another one, and then we'll be done. Okay. All right, I had to pause and come up with a graph that would work for this example. So I've got a graph that looks like this. It's got a vertical asymptote at x equals -5, a vertical asymptote at x equals 4. It has a 0 at x equals 1. I have to extend this. And it looks more or less like this. Again, if I look at this, so that's the point 1, 0 right there. If I look at this, it doesn't look like there's a whole lot of information because it's basically just lines. We are used to seeing points to help us solve things. But with rational functions, you have to get used to having lines help you solve things. And one more thing. I messed this up. I'm going to start again. There's -5. There's 4. There is a horizontal asymptote at y equals 2. That's what I had messed up from what I drew earlier. So this is coming down towards y equals 2. And this is coming down towards y equals 2. And that's the point 1, 0. Okay. So again, mostly we're having to use lines to help us figure out the formula, which is much more challenging than points because points, the information is more obvious to us. But we'll start the same way. We'll identify the roots. In this case, there's 1. It's at x equals 1 right there. Then we'll identify the vertical asymptotes. There are 2 at x equals -5 and x equals +4. The horizontal asymptote, we have a horizontal asymptote at y equals 2. And there's a y-intercept, but we don't have any information about that yet, and that's okay. So now let's put our formula together. I'll do it here. So we have a root of x -1 in the numerator, and we have 2 vertical asymptotes in the denominator. Now our end behavior looks like a straight line, and it's not 0. So, and in addition, if we take our window right around our root, we see that it's bouncing off. So this root actually has an even multiplicity, just like in polynomials. So rational roots have multiplicity. That has an even multiplicity, so it's probably a multiplicity of 2. Now when I think about what this function looks like, it's going to be similar to x squared over x squared, which is just 1. And the problem with this is my horizontal asymptote is at y equals 2. So to fix that, I need to put a 2 right here. And now my function looks like 2x squared over x squared, which equals 2. And that's my horizontal asymptote. So in this case, instead of having an extra point to figure out the leading coefficient, we use the extra line of the horizontal asymptote to figure out the leading coefficient. If this didn't make sense, watch the video again. If it doesn't make sense after that, come to office hours or find another resource like the Math and Statistics Learning Center, because these questions here require a lot of practice, and a lot of getting comfortable with using features of graph that we're not used to in order to come up with possible formulas for our function.